Okay, hi, A2 kiddos. So today we're looking at lesson 1-4, and that is a review of the exponents that we looked at last year. So you hopefully remember that exponents represent repeated multiplication. I have a base that's being raised to a smaller exponent. 4 to the third power means 4 times 4 times 4. That repeated multiplication. You also might be remembering these binomial squares, these keywords, double distribute problems. Remember, when you're looking at that binomial squared, the first thing that you want to start with, or the first thing that you want to do, is you want to expand it first. Just like we did up here, if we have 4 to the third power, that meant 4 times 4 times 4. If we come back up here for a sec, and if we have, 2 plus x squared, that means 2 plus x times 2 plus x. You're taking that entire base, which is what the parentheses are showing you, and multiplying it by itself. So here in this first example, before we get started, we need to expand that too. 4x minus 2 squared means 4x minus 2 times 4x minus 2. Now we can go through that double distribution process. 4x times 4x, well, 4 times 4 gives me the 16. X times x gives me x squared. 4x times negative 2 is negative 8x. Negative 2 times 4x is another negative 8x. And negative 2 times that negative 2 is a positive 4. Take one last step and combine some like terms. 16x squared, negative 8 minus 8 more is negative 16x. The exponents aren't changing here because I'm just subtracting them. And that 4 can carry down. And there's our final simplified answer. In our second example, excuse me, we're looking at a slightly different rule when we're dealing with multiplication. Remember, when you've got those multiplications, you're looking for, first off, you need to have, let's go purple, you need to make sure that your bases are the same. Your bases must be the same when you're dealing with those multiplications pieces. And when you're multiplying, you add the exponents. So what I mean by that is if you have something like x to the third power times x to the fifth power, that would turn into x to the eighth power. Because again, if I expanded this, that would be x times x times x. Oops. And if I expanded this, that would be x times x times x times x times x, for a total of 8 of those x's, bringing that to an exponent of 8. So over here in our example 2, I should have broken this up into different videos. Sorry about that. In example 2 here, we're looking and we're trying to figure out which ones have the same bases, kind of like terms, which pieces are similar that I can combine. So I can see here that I have an A, and I also have an A over here. So a to the third times a to the ninth, again, I'm adding those exponents, so 9, 10, 11, 12 will give me a to the 12th. I have a b, and careful, because that exponent of 5 is only on the c. That exponent of 5 is not part of that b. The b, if there's no exponent written there, we assume that that's an exponent of 1. So we've got a b to the 1 and a b to the 4th that we can combine to get b to the 5th. We have a c to the 5th and a c to the negative 2, which 5 plus negative 2 is just 5 minus 2. So we have c to the 3rd. And then that 0 exponent. It's been a hot minute since we talked about 0 exponents. Let's look at that real quick. 0 exponents. And an easy way to do this, if you don't remember, you can easily just take this and plug this into your calculator. Pick any number and plug it into the 0 power and see what happens. 0 exponents, and I guess I can show you that real quick. Let's move that up. Okay, just kidding. So if I do, 8 caret 0, enter, you'll see that 8 to the 0 power is 1. 450, whatever big number to the 0 power is 1. So 0 exponents, anything, let's not use bright green though, let's go back to black. Anything raised to a 0 power is 1. Always. Always. So that means that this d piece just turns into a 1, which when I multiply all that stuff by 1, it doesn't really do anything. So my final answer is just a to the 12th, b to the 5th, and c to the 3rd. Simplified. Let's take a break and we'll do the other examples in a different video.